Why do some objects move while others just stay at rest? Sir Isaac Newton came along and developed the three laws of motion, which helped explain why and how objects move. The first law. An object free from external force will continue moving at constant velocity or remain at rest. So, if Batman is standing on an imaginary gargoyle, he will stay there at rest unless he exerts some kind of force. If Batman is in a vacuum, however, and he's going at a speed, he will stay at that constant speed unless acted by another force, such as hitting the ground. The second law. Newton's second law states that force equals mass times acceleration. As you can see, force and mass are both vectors, and the direction therefore matters. Force and acceleration will have the same direction. The units, kilograms, times acceleration, which is meters per second squared, is 1 Newton, which has the variable n. So, when Batman exerts a force on Joker, this will cause Joker to accelerate backwards and fall back. Before we talk about the third law, we're going to talk about forces. A force is either a push or pull, which tends to change in the object's motion. And as I said before, the direction of the force will be the direction of the acceleration. So let's look at non-contact forces. For example, gravitational forces, which has no contact on an object, yet it does act as a force that pulls an object towards the earth, such as seen when Batman is simply dropped, it will fall to the ground. The acceleration of gravity is 9.8 meters per second squared, and this is called the gravitational constant, g. The gravitational force is also called weight, and the weight is equal to mass times g, where g is the gravitational acceleration. Please note that weight is a force and it is different than mass. Now let's look at contact forces. For example, frictional forces, which is a force that's generated by two surfaces that contact and slide against each other. As seen in the picture, the ground and the cupboard are in contact together, and this causes a force of friction. Now let's look at the third law. The third law is also known as the action-reaction law. It is because if an object A, in this case the finger, exerts a force on object B, the wall, object B will exert an equal and opposite force back on A. In our example, an action-reaction force could be when Batman is trying to jump. When he's trying to jump, trying to apply a force that's downward onto the ground. But the downward force will cause there to be an upward force due to the ground, which will cause Batman to jump up. Another example is when the Batmobile is driving. The wheels will be exerting a force that's backwards, but the earth will propel the Batmobile to go forward due to the action-reaction forces. Another example of an action-reaction force is a normal force, which is exerted upon an object that is in contact with another stable object. For example, in our picture, this box has a gravitational force that's downward, but the normal force due to the table is kind of pushing the box up to counteract the force of gravity. Now let's go back and summarize everything we learned today. An object free from external force will continue moving at constant velocity or remain at rest. So an object at rest will stay at rest, and an object moving will continue moving unless there's another force that counteracts its motion. Now the second law states that force equals mass times acceleration. That means force is directly proportional to acceleration, with the proportionality constant being the mass. The third law states that if an object A exerts a force on object B will exert an equal force back on A. This is also known as the action-reaction force.